Hello and welcome to Async Techniques and Examples in Python. I want to take just a few minutes and show you what this course is all about. Let's start by looking at a topic map of all the stuff we're going to cover and where it fits into the Python async landscape. So we're going to break this into two general areas. One, how to do more at once, scalability, and the other, do things faster, leverage modern CPU cores, take individual computations and make them faster, things like this. In the do more at once side of things, we're going to focus first on the most modern way to write concurrent programs in Python, the new async and await keywords and the asyncio module that underpins it. We're also going to focus on threads. Now, some languages, threads might let you do things faster in the CPU bound sort of way, but in Python, we have the GIL. So we're going to talk about the implications of the GIL, what the challenges of it are, and how to get around it. But that puts threads in the do more at once scalability side of things. In the CPU bound world, we're going to focus on one of the core ways to take Python code itself and make it scale out without being affected by the GIL using multiprocessing. We're also going to learn how to write C code using Cython, which will give us yet another way to take regular Python threads in a single process, which means sharing data is easier, and scale that across CPUs in an incredibly fast way. We're going to take a program that does non-trivial work and make it 1,000 times faster by using Cython. Not 1 or 2 or 5 or 10 times faster, 1,000 times faster. It's going to be really amazing. And finally, we're going to look at a handful of libraries that build on top of things like asyncio, threads, and multiprocessing to put better APIs on this, or to make it easier to do more advanced, more coordinated type of parallelism. One of the areas we're going to focus on in this course is taking advantage of asynchronous programming for speed. We want our CPU cores, our system information to look like this. We don't want to write Python code that just leverages a single core. On this system, we could get 6 times the performance in an ideal world using a couple of the techniques, at least 2 different techniques in Python to take advantage of multi-core systems, which are pretty much all of them these days. You might be interested in async programming for scalability, not doing an individual thing faster, but doing many more of them at the same time without losing performance. Let's just look at how this might work on the web, say. We get 3 requests, they come in, they take as long as these green boxes here. If we try to map out the actual perceived time from the users, they make a request, when do they get a response? We can see things like request 3 are doing terrible. It takes like 5 times as long as it should for the person to make the request 3, to get a response. But with asynchronous programming, we can rewrite this with very little work and get near, not exact, but near instant response time for everything. Why? Why is this possible? It's not magic. It's because on the websites, on web applications, you're almost always just waiting on something else, waiting on a database, waiting on an external web service, waiting on a microservice. With Python's great async support, you'll see that we can take this waiting time and make it productive waiting time with a very small change to our programming model. It's going to be amazing. If you're doing parallelism, you need to think about thread safety. The fundamental problem we have to address is when we call a function, we're going to evolve the state of this application. Along the way, it may enter a temporarily invalid state. Of course, when we get to the end and return the value, everything is good. But in threading, things are different. Maybe along the way, some other thread comes and observes this data before we get a chance to put it back. So we're going to have to use thread safety to make sure that no other thread or part of our program can observe temporarily invalid state. That's super important. We're also going to talk about deadlocks, because as soon as you introduce locks and other issues, you may actually make things worse or create other additional problems. So we'll see how to address those as well. And as I said before, we're going to use multiprocessing to sidestep the GIL. We're going to take a couple of APIs that we can use to leverage multiple processes to sidestep the GIL and take full advantage of modern hardware on straight C Python. We're going to cover these topics and many more. You may be wondering, what are the student prerequisites? Do I have the skills, the experience to take this course? Well, basically, you need to know Python. This is an intermediate level course, at least I would say. It's certainly not a beginner course. We cover a lot of Python concepts, classes, functions, decorators, and so on, without really explaining what those are or what they mean at all. If those types of things are unfamiliar to you, you probably should take a foundational course like my Python Jumpstart by Building 10 Apps, or some other foundational course before you take this one so you can get the most out of it. Finally, I just want to say hi, I'm Michael Kennedy. I'll be your instructor for this course. You can find me online at mkennedy. I started and host the Talk Python to Me podcast, co-host Python Bytes, and am the founder of Talk Python Training. I spent years writing and studying asynchronous code, and I want to help you master async code and async techniques in Python. I hope you take this course. If you're not watching it on the actual website, just visit talkpython.fm/async, and it'll take you right there. Thanks for watching.